Hi, my name is Russell Perscliffe. I head up the software division here at the Semper Group. Traditionally, engineers waste a lot of time and effort with processes like first article inspection, production part approval process and initial sample inspection reports, from ballooning of drawings, creating reports and transferring of results measured directly at the CMM or vision system. Today we will demonstrate how digitalising the quality and inspection process in line with Industry 4 will save money and add value to any business by eliminating waste, reducing time, mitigating typos and omitting duplication. A fully digitised approach to quality removes the challenge of integrating data from fragmented sources, reduces room for error and enables manufacturers to improve their productivity. Introducing HighQA Inspection Manager, one-click auto ballooning has proven time savings of up to 95% in the FAI PPAP ISIR process. Inspection Manager also allows you to automatically import measured data directly from any machine type. This results in further time savings. In today's session, we will cover one-click auto ballooning from any PDF or TIFF file, and also generation of any dimensional form such as FAI, PPAP, demonstrating traceability and compliance. Okay, so let's start the process from attaching an actual drawing. As you'll see now in a few seconds, we'll have the drawing, which is actually a PDF, and we've attached the drawing, and you'll see on this drawing it has a lot of geometric symbols and general tolerance dimensions. We're going to use this one-click auto ballooning, and I can identify which drawing that I want, or whether I want to balloon all drawings or selected pages from, let's say, a multiple PDF. And I'm also going to use the surface finish detection, because on this actual part there's a lot of surface finish call out, and I'm going to use the OK button. So what we're using now is the OCR, Optical Character Recognition. It's the artificial intelligence within the software to capture all of the symbols and all of the general tolerance dimensions based on the number of decimal places that's actually on the print. Okay, so let's just expand the image and we'll actually fit it to the screen. So you can see now everything has a unique feature number, and what it will do is it will be able to capture all of the information and how the OCR has interpreted it. Anything that has a tolerance that's based on the number of decimal places, it will apply the relevant logic. So in general, if we go and look at this bill of characteristics, the bill of characteristics is all the dimensional information that's been extracted from the drawing. So the dimension numbers, the positions of features in relationship to the grid lines, the type of dimension, the image, and also the nominals, the uppers and the lowers in terms of the tolerances. So again, we can export that out straight to any kind of form, but what I'd like to do now is go to the next phase, which is actually bringing in some data from a measurement routine. We're going to use a vision system for that, which is a Genoptic optic line. Okay, so what we're going to do now is go and take the direct measurements from the machine. So I'm just going to start the machine. What this is going to do now very quickly is actually measure the component with all the dimensions that we've actually ballooned, and you'll see now it's doing that and it's processing the data, and you can see here straight away we have whether the features are in or out of tolerance. We also have on the right hand side another display here, which is actually an application that will analyze data and harvest data, but again it will do it very quickly and efficiently and tell you whether your process is capable for it, so calculations like CP, PPK, etc. Very quickly now we've actually completed the measurement routine. So what we're going to do then is absorb the data and automate that process of the data directly from the machine straight back into the HighQA software. Wow. Okay, so now we've done the measurement routine and we've collected the data. What we want to do is actually absorb that data, and we can fully automate that, and we can take the data from any machine readable format such as a text file or a CSV file, and you'll see this is the file in question. And the way that it works is the minute the CMM programmer puts it onto a network location, it will actually schedule and it will take the data. So the software will automatically look for a part number and a revision level Okay, so now the CMM program has absorbed those results and posted it onto a folder location. The software will set up schedulers, so the lowest denominator is around about a minute to actually go and look for the data. And then it might take a few seconds or a minute depending on the amount of data that you have. But the idea is the data will be automatic, so directly from the CMM into the application itself. So what I'm going to do now is actually go and review that data, so that here we can see the results. If I select OK, instantly I will have the data. So we have results that's showing as out of tolerance and results that's showing intolerance. If I select a feature, it calculates why it's out of tolerance and any deviation and out of tolerance from the nominal. Okay, so to complete this process, finally we're going to import the data directly into a dimensional form. So it could be an AIS 902, could be a PPAP dimensional form. And the way we do that is this here, inspection reports, single piece. So if it's an AIS 902 and we wanted all the dimensional information for that lot to go into that report, I could generate the report, and you'll see in a few seconds we've now Form 1, Form 2 and also Form 3. So now we have a compliant report for AIS 9102 with all the dimensional information, and we also have the results demonstrating any features in or out of tolerance. Likewise, if you wanted to output to, let's say, a PPAP dimensional report, which could be a combination of multiple results, we can go and select multi-piece form. And again, if we had multiple results, we could select which results we want, and then we can go and say generate it. So when we generate that report, this will be a slightly different variation of a form, but as you can see, it allows us to upload up to 8 sets of results. So these forms can be fully customizable to cater for any number of results. The headers, the columns, you could add your logos. All of these allow the ability to be flexible and customizable to meet your internal process or your customers, so allowing you to be fully compliant in the process. Okay, so the final piece of the puzzle is around collating data from the shop floor. So we've demonstrated how we can automate data from the CMM or any CMM. In particular, we used obviously a vision system, but now we want to focus on what about all of the manuals, so mics, verniers, height gauges. Well, we use an application called IME, so Explore or Express. It's part of the application HighQA, but what it allows us to do is use a simple web browser. So we can physically log in with a unique password and username. When we log in to a home page, which is allowing us to see recently opened parts or physically search for a part. So I'm just going to go and select the relevant part, which is the one we was working on, where we collated all of the data from the CMM. So what I'm demonstrating is now we could use, like I say, mics, verniers, height gauges and so on. So we physically select the part, we highlight it, we can use and define what job. So we might have multiple jobs for this particular part, so we can select the job that we want. Again, when we highlight it, it will give us some KPIs around the total of dimensions, how many have been inspected or not. And again, we can go and select whether we want to collate multiple results. So if we've got a batch size of say 10, we can select we want to collect multiple results, or if it's a single result. As we select it, you can see this already results resides against those features. So it will take me to the next feature, and you can see here now this is flashing telling me it wants a result. So again, this could be installed on a touchscreen monitor, which could be let's say a PC, could be a laptop, could be a physical tablet that could be on the shop floor. So I can go and enter a result. As I go and enter a result, you'll see this straight away goes green and it takes us to the next dimension. Again, select a result. Now again, this could be linked to a vernier, or it could be Bluetooth wireless, and we go and select the result. So physically you can see now, really simple concept around collecting data from the shop floor. It also allows us to collect data in terms of, or analyze data from not just results, but what equipment we want to use. So the tool, the gauge. So if it's a vernier with a designated serial number, I could have that level of visibility or traceability of the equipment that we've actually used. Even down to, we can designate certain operations. So if we've got multiple operations here, I could actually say that op 10 is everything measured on a CMM, and op 20 is everything measured with a vernier or a micrometer. And it will only show me features that need measuring at that operation. So again, we're demonstrating ballooning of the drawing, we're demonstrating automation data from the CMM, but we're also physically linking all of these manual results from, again, lots of different equipment on the shop floor, to finally then be able to create a report similar to what we did earlier, where it will show us all of the data that's linked to the database. So this is at an inspector level, and obviously HighQA is more at the admin level, where you've done all the ballooning and you've defined the process steps that you want to follow. But ultimately all the data is absorbed into one database, so that when we finally create the report, we'll have all the data from CMMs and we'll have all the results from mics, verniers, etc., with all of that level of control and visibility.